Let me introduce myself. My name is Abx Hanifan with NIM 21055-31084 and lecturer Profesor Dr. Tjokorda Gede Tirta Nindhia, STMT from Mechanical Engineering, University of Udayana. And today I'm going to talk about metal forming process, sawing, thermal cutting, electrical machining process, and finished machining operation. The subject I took from Handbook of Manufacturing Processes, How Product, Component, and Material Are Made by James Dirbrella. First process is sawing. Sawing is used to separate work part into two or more pieces, or to cut off an unwanted section of a part. A saw, which contains a series of cutting edges that pass against the work in a continuous as the cutter is advanced into the work. Material is removed by each tooth, and the slot is formed, eventually extending through the entire thickness of the workpiece and severing it into two pieces. The cutter can be in disc, bend, or reciprocating blade form. The operation is used to cut billet, extrusion, casting, forging, and various other shapes into blank for further operation. In this image, this is that called tooth in the saw, and this is this blade. First one form sawing is circular sawing. Use a saw in the form of circular disc with cutting teeth on the periphery. Circular sawing involves the use of rotating cutting blade that can be fed horizontally, vertically, or at angle into the material. Circular sawing is highly accurate because of the rigidity of the machine and the cutting blade. Circular saws for metal cutting are sometimes called cold saw because they don't significantly hit the workpiece as friction saws do. The process can be produced burr-free surface and can reduce the need of secondary finishing operation. Next one is bend sawing. It's most commonly of cut-off operation. The saw is an endless steel bend with cutting teeth on one edge. The blade moves as it cuts in one direction. Cutting is continuous and blade wear is uniform over the whole length of the blade. Since the blade is normally thin, little material is lost to chip, waste, and power requirement are mounts. The workpiece or the blade can be fed manually or mechanically. The bend saw is useful for cutting stock to size and roughing out shape. It contains a serrated blade that forms one continuous loop. The blade is stretched over two pulleys and upper one is idle, the lower one driven by a variable speed electric motor. And this is a
Having a
process
bandsaw in your
of
shop
bandsaw.
adds a lot of different cutting capabilities to your arsenal. And the table saw gives you right angle cuts. The bandsaw can add curved cuts as well as resawing and even safer ripping than you can do on a table saw. But let's look at the saw itself first and just understand how it works. Basically, the bandsaw is just what it sounds like. It's a big looping saw blade.
Next one is contour sawing. Use a bandsaw. The powered band normally moves vertically downward, and workpiece resting on a horizontal table is fed into the moving blade either manually, with or without power assist, or automatically into a moving blade. The cut can be in a straight line or curved path, depending on the shape of the part to be produced.
In this video,
Next is hacksawing. Hacksaw is a hand-powered small-tooth saw used for cutting metal pipes, rod, bracket, and other. Hacksaw can also cut through plastic. The hacksaw has a U-shaped frame and handle at one end. Hacksaw have small pin at each end of the frame that retrieve a blade. A tensioner nut or knob is then used to extend the length of the frame, which put tension on the blade and lock in place. Hacksaw are used by plumbers to cut pipes or occasionally by electricians to cut the conduit. Next one is abrasive sawing. An abrasive saw is a power tool used to cut hard material such as metal, concrete, or masonry. It can also be called a cut-off saw or metal chop saw. The abrasive saw typically has a built-in vise or another type of clamping tool. It also has cutting wheels and motor, which are both attached to pivoting arms that mounted on the base plate. The abrasive saw cut with replaceable abrasive disc, which is typically 40 inches. Abrasive saw can be used in many construction projects. Some can be used for dry cutting, wet cutting, bench grinding, or backstack grinding. The tool can also be used in production of auto parts, ceramic, and glass plastic. Next one is diamond edge sawing. It's kind of abrasive sawing that uses diamond abrasive particle because of particular hardness of the workpiece material. Cutting of ceramic, glass, stone, carbide, hardened die steel, nickel, and cobalt alloy are typical applications. Next up is friction sawing. Friction sawing is a friction sawing process in which material is melted and cut with a pressed blade. The sawing process is that the workpiece is clamped and processed by a knife that has tooth shape not for cutting. Friction between the blade and the workpiece allows the material to heat up. The hot material becomes soft and allows the knife cut through material. The advantage of the friction sawing is following are the advantages: can cut very hard material, can cut very thin material that can damage the saw tooth can be cut easily, and longer saw blade life. Next one is flame cutting or thermal cutting. Primarily means that the use of energy in various forms to cut virtually any shape from iron and non-ferrous material out of sheet or larger slab. These are the grades of the material which are usually referred as flat in the metal processing industry. The other type of the metal is available in angle, channel, beams and pipe, rod and other, which are called the long. The series of articles would cover primarily the cutting of the flat and add later that longs. Next is oxy-fuel gas cutting or OFC. It's a thermal cutting process that uses oxygen and fuel gas, such as acetylene, propane, MAPP, propylene, and natural gas, to cut through material. The oxy-fuel process is the most widely applied industrial thermal cutting process because it can cut thickness from 0.5 mm to 250 mm. The equipment is low cost and can be used manually or mechanically. There are several fuel gas and nozzle design options that can significantly enhance performance in terms of cut quality and cutting speed. Next one is metal powder cutting or POC. This method applicable to metal that do not flame cut very easily. Preheated iron powder is injected into the flame to raise the cutting temperature. Oxidation of the iron provides an aid to cutting metals that are highly resistant to oxidation. It is also used to remove gates and rise from iron and stainless steel casting, and to cut steak, sheet, or plate more easily. Next one is chemical flux cutting. It's an oxygen cutting process in which metals are severed using a chemical flux to facilitate cutting, and powdered chemicals are utilized in the same way as iron powder is used in the metal powder cutting process. This process is sometimes called flux injection cutting. Next is arc cutting. Arc cutting is a process of removing metal by means of heat generated from the carbon arc. This process employs a carbon or graphite electrode, compressed air, and standard power source. The instance of heat are created between the electrode and a metal workpiece, cut and melt the workpiece.
Alright YouTube, well, I found out.
Next is laser cutting. It's a material cutting method that uses an intensely focused, coherent stream of light to cut through metal, paper, wood, and acrylic. It is a subtractive process that removes material during the cutting process using vaporization, melting, chemical ablation, or controlled crack propagation. Laser optic, controlled by computer numeric control, can be drill hole as small as 5 micron. The process doesn't produce residual stress on material, making it possible to cut fragile and brittle material. Laser drilling uses several methods, including single shot, percussing, trepanning, and helical. Single shot and percussing laser drilling produce holes at a higher rate than the other process. Trepanning and helical drilling produce more accurate, higher quality holes. Next is electrical machining process. Electrochemical machining uses both an electrolyte solution and electrical current to alter the workpiece. Because electrical conductivity is necessary for electrochemical machining, the workpiece material must be conductive. Electrochemical machining is the opposite process to electrochemical or galvanic coating. In electrochemical machining, the workpiece is taken as the anode, and the tool is taken as the cathode. These are both placed in the electrode solution, and electrical current is passed through the solution between them. The workpiece tools are placed very close to each other, but are not touching. As the electrical current is applied, the material removed from the workpiece happens at the atomic level, producing the smooth finish. First one is electrical discharge machining. It's non-traditional machining process based on removing material from a part by means of the series of repeated electrical discharge between tools, called electrode, and the part being machined is the presence of the dielectric fluid. Next is electrochemical machining. It's a method that finishes the workpiece surface by means of anodic solution. The machining tool is cathode, and the arc under DC current is the presence of electroda fluid to create an anodic reaction that removes workpiece surface material in process. ECM, or electrochemical machining, utilizes chemical reaction through electrical charge, resulting in anode dissolution of the workpiece material by the electrode, both of which are conductive. Electricity with high strong current and low voltage is used to dissolve the metal particle of the workpiece. The voltage source is used in DC current through an electrolyte reaction intermediate that flow in the gap between the two workpiece and electrode. Next is electrochemical discharge grinding. It's a hybrid of two non-traditional processes. Material is removed through the combination action of electrochemical dissolution as in electrochemical grinding, and spark erosion as in electrical discharge grinding. Like ECG or ECDG is also able to operate at high current density and increased removal rate because the oxide layer is removed by spark erosion. Two forms of electrical energy are used to remove material. These machines are very similar in construction machine and can be tailored to perform the same function: phase, plunge, surface, and internal grinding. Next is electrochemical honing. It's one of the most advanced precision machining processes used for finishing of cylindrical and gear. Based on the combination of electrochemical machining process having high material removal rate and generation of controlled smooth surface finish by conventional honing process. ECH can remove material at rates up to 100% faster than conventional honing, the gain being more pronounced as the material hardness increase. Machine capacity are currently able to accommodate bore length up to 6300 mm and bore diameter from 9.5 to 150 mm. Next is electro-etching. It's a method for marking workpieces that are electrically conductive. A stencil is placed on the workpiece and a pad containing an electrolyte is placed or dabbed on the stencil. The workpiece and the pad are connected to source of the direct electrical current. The current removes workpiece material electrolytically in the area corresponding to an opening in the stencil. The method is useful for placing identification marking on metal. Electro-etching is normally performed manually and is a suitable method when producing quantities are modest. Next is finish machining operation. First one is honing. Honing is an abrasive process that is carried out using a number of abrasive rods. The number of abrasive rods depends on the size of the hole. 2 to 4 rods are used for small holes, and 12 or more rods are used for larger diameter hole. Honing is an abrasive machining process that produces a precision surface on a metal workpiece by rubbing an abrasive scarping stone along the control pad. Honing is mainly used to correct surface geometric shape, but can also improve surface texture. Typical applications are finished cylinder for internal combustion engines, air bearing, spindle, and gears. This is the honing spindle, honing tool and the workpiece, and honing fixture. This is the operation. Next is lapping. Lapping is a machining process in which two surfaces are rubbed together with an abrasive between them by hand movement or using machine. Define lapping. The term lapping is used to describe a number of various surface finishing operations where loose abrasive powder are used as the grinding agent at normally low speed. It is a process reserved for a product that demands very tight tolerance and flatness.
Lapping. Let us see an example for lapping operation. Lapping is a surface finishing operation. It consists of abrasive table, workpiece, abrasive wheel, lapping tool. The lapping process uses
This
the
is the lapping
abrasive
process.
tool and dry polish wheel or abrasive particles and vibrates with workpiece between the lapping tool.
Next is super finishing. Process remove to amorphous surface layer, increasing the life of a part by helping decrease wear and tear while achieving better sealing capability. This process allows for a repeatable, predictable finish which is isopatic, that is uniform in direction. Finishing process include preparatory treatment used before additional treatment, such as bleaching prior to dyeing, treatment such as glazing to enhance appearance, sizing, affection touch, and treatment adding properties to enhance performance such as fast shrinking. Next is burnishing. This means of smoothing machine or other surface by rubbing a smooth hard object against the surface with considerable pressure. Burnishing is not a machining operation, but instead deform and press down localized high spot from cutting tools and thereby smooth rough area.
Burnishing. In this video, we are going to see about burnishing. Burnishing is a cold working process in which plastic deformation occurs by applying a pressure through a ball or roller on metallic surfaces. Consider a hollow cylindrical workpiece held in a lathe. A burnishing tool develops a finished surface on turned or bored metal surface by
Next one is roller burnishing. Refine the surface of workpiece by pressing, rolling, rather than by removing metal. The burnishing tool incorporates one of more hardened, finely polished roller, which bear against the workpiece at high pressure. Each roller achieves the desired effect by deforming the surface material of the workpiece as it rolls against it, compressing the minute peaks of surface roughness into the valley. The force applied to the burnishing tool depends on the amount of pressure required to exceed the yield point of the workpiece material. Multiple rollers may be used, depending on the shape of the surface being roller burnished. Gear tooth finish is one common burnishing operation, performed by rolling the gear workpiece against three smooth hardened burnishing. Thank you.